हाँ लाइव हो गया मैंने वो.
Okay, students, good morning. Today is the 6th day of our training program, that is certificate course on immunological techniques. And today we have with us Dr. Dipti Malik, who is associate professor in the Department of Microbiology, Dolphin Institute, Dehradun. She has more than 20 years of experience in teaching of UG and PG students, and today she will be demonstrating rocket immuno electrophoresis, and you will be exposed, means you will be conducting also the rocket electrophoresis with her. So please join me in welcoming Dr. Dipti Malik.
Thank you so much. Thank you, sir, for this formal introduction. So today morning you are continuing with your workshop series. You have studied a lot of techniques, and today's technique which we are going to learn is rocket immuno electrophoresis. So this is also abbreviated as RIEP or the RIEP. हम हर टेक्निक को शॉर्ट में बोलते हैं, ठीक है, ताकि हम उसको इजीली बोल सके. So in short we can call it RIEP or RIEP. So here on the screen, as you are seeing the rocket. So I think when you're seeing some animated lecture, and this is related to your lecture, so there might be questions. Where is the rocket here? Obviously, in this laboratory, you can't imagine a rocket here. So rocket word, which we have used here, and we are seeing the rocket animated strip. So this will be somewhere in this lecture. You will get to know why this technique is called rocket immuno electrophoresis. तो इसमें rocket जो है कहाँ से आएगा? Change cases. So this technique is introduced by Laurel long back in 1966. जब Laurel ने इसको introduce किया, so he carried this technique for the detection and estimation of a virus. That virus is the infectious bursal disease virus. This virus was infecting the chicken. So he took the samples from the experimentally infected chicken. लैब में उसने चिकन को इन्फेक्ट किया और उनके सीरम सैंपल्स लिए, और साथ में उसने कुछ ऐसे सैंपल्स भी लिए जो कि आउटब्रेक से लिए गए थे. जब इस डिजीज की वायरल डिजीज का आउटब्रेक हो रहा था तो वहां से भी सैंपल लिए. So he was having what? He was having the standard samples and he was having the samples from the infected cases. तो हम स्टैंडर्ड बोल सकते हैं और पेशेंट बोल सकते हैं. सो ही वाज ट्राइंग टू सी कि वायरस जो है ये कितना आ रहा है इन्फेक्टेड में एज कंपेयर टू द स्टैंडर्ड. सो ही वांटेड टू क्वांटिफाई. सो व्हेन देयर इज अ डिजीज, as you are dealing with diagnosis, most of you are studying the diagnosis in your theory papers. So when we study a disease, so it's marker. The marker here is what the marker? The antigen. So antigen is coming in the infected sample, and we want to see how much antigen is there. So that's why these are carried out to see how much infected sample is there, how much infection is there. तो कितना antigen है उसे पता चलेगा कि कितना इसमें जो है they will give how much of the infection. Just a minute. solidify We will see, first of all, the literal meaning of this technique, rocket Immuno Electrophoresis. We can break it into different parts, 4 parts you can see. So rocket is a shape. We are using the word rocket here to see the shape of the tail of the rocket. तो जब rocket launch होता है, पीछे से जो tail निकलती है, the fumes which come out, that come in a particular shape. So we have used the rocket here for the shape of the rocket as well as the shape of the comet which you have seen. धूमकेतु जो आप देखते हैं, तो उसकी shape से. Then immuno involves the immunological molecules. Here the antigen and the antibody. The electro is for electric field and phoresis is for the movement. So in सबको अगर हम join करें, so here what we are seeing the movement of the antigen antibody, and as we see, this is under the influence of the current, under the influence of the electric field. So when they will interact, they will produce something like rocket. So that's why this is called rocket Immuno Electrophoresis. So before we come to this technique, let's see how much we are having the concept of antigen and antibody. कितना पता है हमें antigen antibody के बारे में? So what is antigen? Anyone of you? I will ask one by one. Yes, what is an antigen?
Antigen was the protein.
Antigen is
Was the protein which is foreign particle. Also, the antibody. Antigen is foreign particle which could be polysaccharide, carbohydrate.
okay. So as per you, antigen is a foreign particle. Okay. Any other definition?
Antigen is a foreign substance that can elicit our immune response towards that.
Okay. So अभी तो जितना आप लोगों ने immunology पढ़ा है और जिसने immunology नहीं भी पढ़ा, एंटीजन हमें पता है कि एंटीजन कहाँ से आ रहा है, बाहर से आ रहा है. So it is a foreign substance. हमारा अपना नहीं है. It is coming from outside our body. So it is coming in our body and it is initiating an immune response. Our body tries to fight against it. It initiates an immune response. So as I said, antigen can be a carbohydrate. It can be a lipid. It can be a protein. These can also be nucleic acids. Okay. And now, what is antibody?
Not efficient.
Anyone? Yes, you want to tell? Yes.
Antibody is also known as immunoglobulin, and it is a large Y-shaped protein.
So antibody, very good, is also immunoglobulin. It has got the Y-shaped structure, and antibodies, they are produced in the body of the host. तो जब हमें बाहर से कहीं एंटीजन कोशिश करता है आने की, तो हमारी बॉडी कोशिश करती है कि उससे फाइट करे. हमारी बॉडी के पास इम्यून सिस्टम है, so we try to fight against. So for fighting against these particles, which are called antibody, these molecules, these are produced. So antibody is produced against the antigen. Now in this animation you can see this is the antigen, okay, and as a structure है इसका that you can see a pointed head, a wing-like structure, but actually antigen को हम किसी proper structure से, proper shape से define नहीं कर सकते. So it is showing that there are some specks present on the surface of the antigen. This a pointed structure, these are called epitopes or antigenic determinants. So when this antigen enters the body of the host body, it produces the antibody. And this antibody, as you have told that this is the Y-shaped structure, and this antigen will bind to this antibody. You can see this is the pointed structure. It will fit into this antibody. Okay, and as it will fit into this antibody, then by different mechanisms, this antibody will try to fight against, will try to nullify the effect of antigen. जो भी एंटीजन हमारी बॉडी में हार्मफुल इफेक्ट प्रोड्यूस कर रहा है, ये एंटीबॉडी ट्राई करेगी कि उस हार्मफुल इफेक्ट को क्या कर दिया जाए, नलिफाई कर दिया जाए. ओके, so that's why there is an antigen antibody interaction, and this interaction is very specific. Specific means there can be trillions of antigens. जितना हम काउंट भी नहीं कर सकते, हम इमेजिन भी नहीं कर सकते, उतने एंटीजेंस इस दुनिया में प्रेजेंट हैं जो कि हमारी बॉडी में आके इम्यून रिस्पांस को जनरेट कर सकते हैं. और इन एंटीजन के ऊपर स्ट्रक्चर प्रेजेंट होते हैं जिनको बोलते हैं एंटीजेनिक डिटर्मिनेंट्स. हर डिटर्मिनेंट के अगेंस्ट हमारी बॉडी में एंटीबॉडी प्रेजेंट होती है, या हमारी बॉडी की क्षमता होती है, ये गॉट द कैपेसिटी टू प्रोड्यूस द एंटीबॉडी अगेंस्ट ईच एंड एवरी टाइप ऑफ एंटीजन. तो जितने एंटीजेंस हैं उतने ही अलग तरीके के एंटीबॉडी मॉलिक्यूल्स हो सकते हैं. तो हर डिफरेंट एंटीजन के लिए हर डिफरेंट टाइप की क्या होगी, एंटीबॉडी प्रोड्यूस होगी. So this is interacting, antigen is interacting. For interaction, the antibody is having a molecule paratope and the antigen is having the epitope. तो ये epitope इस paratope में आके फिट होना चाहिए. तभी फिट होगा जब इस एंटीजन के लिए ये अगेंस्ट स्पेसिफिक एंटीबॉडी हो. ठीक है, सो दैट इज द स्पेसिफिसिटी ऑफ आवर इम्यून रिस्पांस. हमारा इम्यून रिस्पांस जो बहुत स्पेसिफिक है. जितने अलग-अलग एंटीजन हैं उतने तरह के एंटीबॉडी हैं, और जो पर्टिकुलर वाला एंटीजन होगा उसी के साथ एंटीबॉडी बाइंड करेगी, और जो है हमारा इम्यूनोलॉजिकल रिएक्शन जो है कंप्लीट होगा. वो रिएक्शन हमारी बॉडी के अंदर जब हो रहा है, सो दैट इज इन एलिमिनेटिंग दिस एंटीजन. और इसी कांसेप्ट का हम यूज करते हैं अपने इम्यूनोलॉजिकल रिएक्शंस में. लैबोरेटरी में टेस्टिंग होती है, जब आप सैंपल देके जाते हो वो बोलते हैं कि सीरोलॉजिकल टेस्ट होगा. तो सब सीरोलॉजिकल टेस्ट, जितने सीरोलॉजिकल टेस्ट हैं, दे आर बेस्ड अपॉन दिस प्रिंसिपल ऑफ द स्पेसिफिसिटी बिटवीन द एंटीजन एंड द एंटीबॉडी. इज इट क्लियर? सो दिस इज द थंब रूल. क्या थंब रूल है इम्यूनोलॉजिकल रिएक्शंस का, कि अगर स्पेसिफिक एंटीजन एंटीबॉडी होंगे तभी वो रिएक्ट करेंगे. ठीक है, अनस्पेसिफिक होगा तो कोई रिएक्शन पॉसिबल नहीं. ओके, so this is the rule on the basis of which this particular reaction जो आज टेक्निक पढ़ोगे और बाकी जो टेस्ट हैं वो भी इसी पे बेस्ड होते हैं. Now this figure is not very clear figure. Okay, is there any problem making out? So I'm going to explain you. कुछ format में change है. So I will explain this figure to you that जब antigen antibody interaction होता है, there is a specific amount of antigen, a specific amount of antibody, only then there can be interaction. जब हम दो चीजें ले रहे हैं, एक तो हम सैंपल ले रहे हैं पेशेंट से, दूसरा हम क्या कर रहे हैं, अपना कोई किट का रिएजेंट ले रहे हैं जिसमें एंटीबॉडी प्रेजेंट है. तो हर कॉन्सेंट्रेशन में जो है रिएक्शन नहीं होगा. There has to be a particular relation between the antigen and antibody. So in this case, the antigen and the antibody, if they are soluble, then first case, which is not so very much clear, here the amount of antigen is in excess. तो antigen अगर ज्यादा होगा तो उसे sufficient antibody नहीं मिलेगी combine करने के लिए. We won't be able to see the reaction. Then in the third compartment, this is the first, this is the second, this is the third. In the third one, the antibody molecules, they are more, so the antigen is less. So again, there won't be any particular reaction. But in the center one, there is optimum concentration of the antigen and the antibody. So this phenomenon is called the equivalence zone. जब भी हम कोई अपना प्रोटोकॉल स्टैंडर्डाइज कर रहे हैं, या हमें जिसने मैन्युफैक्चर ने बना के दिया हुआ है, जिस किट कंपनी ने बना के दिया हुआ है, तो वो इस हिसाब से स्टैंडर्डाइज करते हैं कि हमारी जो भी दोनों रिएजेंट जो है एंटीजन और एंटीबॉडी, वो इस इक्विवेलेंस जोन में आए, तभी जो है हमें प्रॉपर जो है रिएक्शन देखने को मिलेगा. So we have to standardize the quantities in such a manner that all the antibody molecule they get sufficient antigen to bind. आपने लास्ट में देखा, इसमें आपको एक्सप्लेनेशन, जिसमें आपको फिगर दिखाया हुआ था, the figure of the Y-shaped molecule. That each antibody will bind with 2 antigen molecules. Okay. So ऐसी concentration होनी चाहिए कि antibody के जो दोनों sides हैं, दो इसकी valency क्या है? 2 valency है. All the valencies they are satisfied so that the reaction can occur. तो अगर ज्यादा होगा इन दोनों में से कुछ भी, then the optimum reaction will not occur. So all this they should point in this equivalence zone. Now again, this is coming back to our technique, which is the RIEP, rocket Immuno Electrophoresis. So I am telling you a bit about electrophoresis also. Electrophoresis का type है, तो so concept of electrophoresis, we know electro is electric field. Phoresis means the movement of charged particles. अब electric field है, so every molecule won't move. We know हमारा current किससे बनता है? Current is because of the movement of electrons. So this movement of electrons is constituting a current, and along with this, the charged particles they will also. So जब electrophoresis है, then only the charged molecules they can. Now, what are these charged molecules? These molecules they can be anions. Anions are negatively charged. So cations they are positively charged. When there is a charge, so they will move according to their charge. Anions will move where negative है तो कहाँ जाएंगे? They will move towards positive. If they are positive, they will move towards negative. So which one is the positive electrode? Which one is negative electrode? हो सकता है कि आप में से सबको नहीं पता हो. So which one is? The cathode is the negative, anode is positive. तो इसको याद करने के लिए trick मैं suggest कर सकती हूँ आपको. As it is anion, negative charge, so it will move to anode. And they are common. ठीक है? Anions going towards anode. Cations going towards cathode. Cat and cat is common. Okay? So two cats here. Take cat कौन सी है? The cations. Other cat is the electrode, which is the cathode. Yes. Now, electrophoresis, it is carried out in a medium. जब हम देखेंगे तो इसको एक medium चाहिए carry out करने के लिए. It requires a gel to carry out electrophoresis. Now, what that gel is? That gel is agar. You might have heard about agar. आप सबने I think agar ने use भी किया culture medium में. Now, why this rose? क्या यहाँ पे कोई rose का extract डलता है? Rose डलता है क्या? No. So what is this agarose? It's a purified, जो कि बहुत अच्छा उसको define कर दिया गया है. Agar को हम बोल सकते हैं crude form में. Agarose is what? It is a purified form. So that's why it is called a purified form. So agarose is added. It is purified form. It is a polymer. These polymers के दो monomers हैं. मतलब तो monomer. It is galactose and 3,6 anhydrogalactose. Now we use it in a particular concentration, 1% to the 3%. This concentration determines the pore size. ज़्यादा concentration बड़ी हो जाएगी तो pore size छोटा होता जाएगा. So 1 to 3% will give it a consistency of like gel-like. जो jellies आप लोग chew करते हैं, so उसकी जो concentration होती है वैसी होती है. It is neither too soft, neither too hard. It is chewable. So similarly, when we are using it 1 to 3%, it is semi-solid, gel-like consistency is there. Agarose is sold in purity grades. इसमें sulfate ions होते हैं. ज़्यादा sulfate होगा तो impure होगा, कम sulfate होगा तो अच्छा होगा. So this agarose gel, it is carried out for the electrophoresis of protein and the DNA molecules. Agarose की property क्या है? It has got a low melting point, 62 to 65 degrees Celsius, and it can be re-liquefied at 65 degree Celsius. So that's why we are using this matrix agarose. इसलिए हम इस agarose का ही gel बना रहे हैं. Now we will just see the experimental setup also. So we are preparing a gel, then we are adding this gel in a buffer 3 mm tip hoga. We load wells in it. In last experiment, you have also made some wells using the gel puncher method. So same method you will use also here. The gel puncher method you will make the wells. Then you will place the gel in the electrophoretic tank, cover it with buffer, and then load the samples in it. The sample will contain a tracking dye. That dye is what? That is bromophenol blue. So it's act like a marker. एंटीजन को हमने कहां डाल दिया है? तो रिमेंबर जो सैंपल है, सैंपल में क्या है? सैंपल कंटेन्स द एंटीजन. सो आवर सैंपल इज वी आर लुकिंग फॉर द एंटीजन एंड नाउ वेयर इज दिस एंटीबॉडी? और तो यहां पे कुछ मिस हो रहा है. सो व्हाट इज द एंटीबॉडी? एंटीबॉडी इज एडेड इन द agarose itself. So we are providing the antibody in the agarose. When we are making the gel, during that process, we are adding the antibody, and in sample, there is the antigen. So last experiment which you have done, that was the experiment I think about the, you have done what? Single radial immunodiffusion. So in that experiment, you also added the antibody in the agarose. So like similar in that manner, here there is also the antibody in the agarose. So antibody is made immobilized. अब एंटीबॉडी को क्या कर रहे हैं? इमोबिलाइज कर दिया, उसको चलने नहीं दे रहे. ठीक है? So that is there. Although it can also move, पर हमने क्या कर दिया है? उसको इमोबिलाइज कर. कैसे इमोबिलाइज कर दिया? जो जेल के पोर्स होंगे ना, उनके बीच में क्या है? एंटीबॉडी जाके जो है वो रुक गया है. तो जेल के बीच में ट्रैप हो गया है. तो एंटीबॉडी तो मूव कर सकता है, but it cannot move. Why? Because it is trapped inside the gel. So which can move? Which molecule can move? The antigen can move. So antigen is in the well and antibody is in the gel. Now antigen will move and find its antibody. Antigen चलेगा, जल्दी जल्दी क्या करेगा? Antibody को ढूंढेगा. जहां से एंटीबॉडी मिल गई वहां क्या होगा? ये देखिए binding, a specific binding between the antigen and the antibody. Okay, so when there is binding, तो वो binding हमको देखनी है. So that binding will be seen in the form of the bands. You have also seen the bands, but the difference between that technique, the immunodiffusion and electrophoresis, is that we didn't consider anything of the charge of the molecule. Here we are considering the charge also. The antigens, they are negatively charged. जो हमारे पास एंटीजन है, so that we have loaded in such a manner कि हमारे एंटीजन्स जो है वो कैसे हैं? Negatively charged हैं, and the antibody is present in the gel, and antigen is going from there negative to the positive side. So when we are doing this technique, क्यों कर रहे हैं टेक्निक? क्योंकि immunodiffusion तो है ही है, साथ साथ में हमारा क्या है? इलेक्ट्रिक करंट भी है. तो immunodiffusion से sensitive method हो जाएगा. You may ask कि हमने कल immunodiffusion किया तो simple method था. Now why we are using this so much of setup? ऐसा क्यों इतना बड़ा method कर रहे हैं जब हमने simply method कर चुके हैं? Then why this method? This method is a better method in the terms of sensitivity. I hope you understand the sensitivity. Sensitivity क्या है? Can anyone tell it sensitivity? बहुत सारे टेस्ट होते हैं हमारे पास. We can go for the exhibition test also, जो आप antigen antibody मिलाते हैं. Then we can go for electrophoretic test. We can go for the chromatographic test. We can go for the PCR. We can go for Western blot. So एक disease के लिए बहुत सारे method diagnosis के, which method we prefer? That method depends upon the sensitivity. So why we go for sensitivity? Because if there is lesser of the antigen in the sample, we want to get it detected. हम चाहते हैं अगर थोड़ा सा भी एंटीजन है तो हमारे डायग्नोस्टिक टेस्ट से क्या हो जाए, वो सामने आ जाए, हमारे टेस्ट में उसका पॉजिटिव रिजल्ट आ जाए. तो So that's why we are going for a sensitive test. So this test is quite a sensitive test. So that's why we are going for this test. So it is better than the immunodiffusion, although there is diffusion भी हो रहा है, but that diffusion is under the electric current. So in this method, we are not only it is both qualitative as well as quantitative. Okay, so we can carry this test. We will just see कि हम कैसे इसे quantify भी कर पाएंगे. Very good thing you have suggested कि हम ऐसा नहीं है कि हम सब एंटीजन एंटीबॉडी है ये देख रहे हैं, इसके साथ साथ में हम एंटीजन को हम क्वांटिफाई भी कर सकते हैं. So we can quantify the antigen also in the unknown sample. So when sample is there, we will be able to quantify it. और थोड़ा सा amount भी है, even which is in the micrograms. Even then वो antigen भी जो है इस test से हम detect कर सकते हैं. So that's why it is sensitive now. So antigen is loaded in the well. Antibody कहाँ present है? In the gel. Okay, it is entrapped. It is immobilized in the gel. So antigen moving towards the antibody. It will find the antibody molecule, they will combine together and they will show some bands. So as the antigen is going towards the antibody we can call it antiserum also. So when they will bind together, there is specific reaction, then they will form the precipitin reaction, they will show some precipitates, and those precipitates are in the form of the rocket. So today you have seen the shape of precipitation bands. कौन सी shape थी वो? आज जो आपने results देखे हैं, last experiment किया था, those were in the circle. आपका antigen कहाँ था? Well में था, और antibody कहाँ था आपका? Gel में था. तो antigen चारों तरफ से diffuse कर रहा था. Okay? तो जब से diffuse किया, it matched antibody, it formed a circle, a ring there. Now here antigen कैसे जा रहा है? सीधा जा रहा है. Why? सब कहीं भी जा सकता है ना, जब वैल्यू डाला है तो कहीं भी जा सकता है. But why? क्योंकि उसको खींच के लेके जाया जा रहा है. Something is dragging it. Okay? When you are going from your college to your hostel, पीछे जा रहे हो, ठीक है? तो क्या है? There is lot of distractions there. Some can go to chai tapri. Some can go to where? ऐसा नहीं है, Bharat Mandir is also there, ठीक है? Some can go to your friend's place, वो वहाँ रहता है, सब मिलते हुए चलते हैं, और कॉलेज में से हाथ चल पूछते चलते हैं. तो आप लोग इधर उधर मूव करके वापस कहाँ पहुँच रहे हो? अपने घर पहुँच रहे हो. But if there is a dragging force at your hostel, या आपके घर जो लोग रहते हैं, someone has cooked a special dish for you. तो कहाँ जाओगे? सीधा भागते हुए कहाँ जाओगे? हॉस्टल. और someone is eagerly waiting for you. पता है आपको हॉस्टल में someone is waiting for you, तो मम्मी ने डांट लगाई है, कहीं नहीं जाना, सीधा घर आना है. तो क्या करोगे? सीधा घर जाओगे. क्यों? क्योंकि वहाँ पे एक अट्रैक्शन है, या डांट है, या डर है वहाँ पे. Someone is calling you, so you will go straight there. तो अब एंटीजन ने लास्ट एक्शन में क्या किया? It was moving everywhere. वैसे निकला, यहाँ भी जाएगा, यहाँ भी नहीं जाएगा. But now in this, the antigen is by being dragged by a force. ठीक है? एंटीजन को क्या करते हैं? खींच के रखा हुआ है. एंटीजन हमारा क्या है? एनाइन है. It is negatively charged. So it will go towards positive electrode. That positive electrode is anode. और रास्ते में जब उसको क्या हुआ? एंटीबॉडी मिल गया. रास्ते में फ्रेंड को मिल जाएगा. Then you will obviously shake hand. You will share hi hello. थोड़ी देर रुक भी सकते हो वहाँ पे. So that will form the band. Okay. So हमने अब देखना है band बन जाएगा, और band जो बनेगा, you will see that band is in the shape of the rocket. तो उस रॉकेट की जो है हाइट हम निकाल देंगे. As you have to measure the diameter, I think. So next जब रिजल्ट आएगा, so you will measure the height of that rocket. और कितनी हाइट है? That is proportional to the concentration of the antigen. ठीक है, तो एंटीबॉडी का कंसंट्रेशन वेरिएबल नहीं है, वो फिक्स किया हुआ है हमने। एंटीजन वेरिएबल कंसंट्रेशन में है, कितना एंटीजन है उसको हमें निकालना है। कैसे निकालेंगे? हमने पहले रॉकेट बनाया, रॉकेट की हमने क्या करी, फिर हाइट ली और उससे हम जो है क्वांटिफाई करेंगे। So this is again the principle. Antigen is present in the well, it moves out, it comes into the gel. In the gel there is the antibody. They will form the complex, which antigen antibody complex that we can also call it immune complex. So Ag AB complex, immune complex. Now this immune complex is seen as the visible precipitation. जहाँ दोनों की concentration equivalent amount में होगी, वहीं पे जो है precipitation होगा, वहीं पे band बनेगा. So there you will see the band, visible band is there, and when this band is formed, then this band sometimes this complex becomes large. इतना बड़ा हो जाएगा कि जेल के जो particles हैं उसको निकलने नहीं देंगे, रोक देंगे. तो जहाँ-जहाँ antibody complex बड़ा हो गया size में, it will get trapped inside the gel, then you can see the precipitation there. Combine तो शुरू में भी कर रहे हो, कहीं और भी करेंगे ये, but एक particular fashion में क्यों देख रहे हो? क्योंकि वहाँ पे जो है एंटीजन एंटीबॉडी का जो कॉम्प्लेक्स बनेगा, वो कॉम्प्लेक्स इतना बड़ा हो गया है that it will find a band there. It is so heavy, so large in size that it cannot move. Okay. So that's why we will see the precipitant bands there. So these bands, they are seen white, आपको दिखाई देंगे visible eye से, or you can see it under the dark black background. जो length होगी या जो area होगा इस band का, that is proportional to the concentration of the antigen. So again you can see this rocket shape here. दिख रहा है rocket? So ये rocket जो अब launch हो चुका है, पीछे इसकी tail बन गई है. ये tail, that's why because of the shape, this kind of shape you are going to see in your gels. So this length of the rocket you will determine this length. The length of this rocket is proportional to the concentration of the antigen. So this is how your gel will look like when we will make a gel. This is the glass plate, जिसके ऊपर gel बनेगा. You lay down your agarose. The antibody is present in the agarose, and the antigen, they are loaded in the wells. In some wells, we load the standard antigen. Standard means we know, no, हमें पता है, वो already हमारे पास है. कितना उस preparation में कितना antigen है, that is already known to us. So in some wells, say in 3 wells, we are going to load our standard antigen followed by the sample. Okay. Then as the concentration of the antigen increases, you can see the bands, they also increase. Okay. So they will we will see higher the concentration, the antigen will move further, it will interact with the antibody and it will form the precipitant peaks. Satish, Dinesh को बोले कितने हैं? So what are the requirements? Now that we know the principle, अब principle clear हो गया हमें कि कैसे करने हैं हमें. So now we should have the requirements and the exact protocol. The exact protocol I will be sharing in the WhatsApp group. We are having some hard copies also. But first of all, let me explain you. So first one is the agarose. We have to prepare an agarose gel. Then we require a buffer, that TBE buffer. TBE stands for triborate. Very good. Then antiserum. Antiserum means the antibody. Then the standard antigens should be there. हमारे किट में जो है स्टैंडर्ड एंटीजेंस हैं, these are from 1, 2, 3 and 4. Test antigen A, test antigen B. That means these are the samples जिसमें कि हमें quantify करना है. How much unknown samples which we want to know how much antigen is there. Then there is a template, there is a glass plate, and there is gel culture. So some of these details you are aware of. You have used in your previous experiment also. Now here we require a horizontal gel assembly and we require a power pack. Okay? This is the horizontal gel assembly. This is the power pack. Power pack इसलिए है इलेक्ट्रिक करंट हम यहाँ से कर सकते हैं सॉकेट से. क्यों? That is जो हमारे सर्किट्स में आ रहा है flowing in this room, that is the AC. यहाँ में क्या चाहिए? We require the DC for the optimal movement. AC में कभी रुकेगा, पोलैरिटी होती है ना प्लस माइनस की, तो वो उससे कंफ्यूज रहेगा हमारा जो आयन है, that will not move. तो हमें एक प्रॉपर DC करंट चाहिए, so that's why we are having the power pack. Okay, how many of you have done the electrophoresis of DNA before? Those who are MSc students, I hope you have done the electrophoresis of DNA in your biotechnology experiments and molecular biology experiments. So even if you have not done, we are starting here from the scratch. You will get to see how do we prepare the gel, how do we load the gel, and how do we set up this assembly. Similar assembly is also used for the DNA electrophoresis. ये assembly है जो हम DNA electrophoresis के लिए यूज करते हैं. So we will see. Just I will demonstrate you how to use this assembly, how to make the gel. So first of all, the first step, you can note the steps in short, or you will get this manual in your WhatsApp group also. You can have the hard copy also, so you can use it. इनके सामने So first of all, a gel is prepared as you are in batches. So each batch will require 15 ml of this gel. So we prepare the agarose gel, the 1% agarose. When we say 1%, that means how much in 100 ml? 1 gram in 100 ml. Okay, very good. Now the cool it to the solution. पहले इसको क्या करेंगे? पहले हमने इसे heat किया. Heat कैसे किया ताकि पूरा जो है ये melt हो जाए. When it gets completely uniformly mixed up, पूरा melt हो गया, then we will let it cool down 55 to 60 or even below it. And then we will add the antiserum. Antibody कब ऐड करेंगे? क्यों करेंगे इसको cool हम? Because अगर हमने hot में डाल दिया तो क्या होगा? It will get denatured. So when हमने solution बना लिया है, then we will check it on earth back of the hand. अगर हमें tolerable लग रहा है ये ठीक से है, अब tolerate हो रहा है हमें अच्छे से, तभी हम इसमें अपना एंटीसीरम डालेंगे. नहीं तो क्या होगा? और एंटीबॉडी जो है वो denature हो जाएगा. The protein it can get denatured. So then we will pour it on the glass plate on a horizontal surface and allow the gel to set for 30 minutes. 30 minutes के लिए उसको set कर देंगे. Now place the gel plate on template. हमारे पास template है, उसको हम रख देंगे. Now we will make the wells with the help of gel culture. जैसे कल आपने बनाया था वैसे ही करना. Then load the wells with the 10 microliter of the antigen, standard antigen, and the test antigen, that means the unknown antigen. So here some concentrations are given for standard antigen. We suppose यहाँ पे A, B, C, D, we are having 4 standard antigens in the variable concentration. You can see the concentration is decreasing. Okay. Then we in the 2 wells or more wells, depending upon the requirement, we will add the test antigen. जो बाकी के wells हैं उसमें test antigen अपना डालेंगे, and then our electrophoresis can be started. So when we are doing the electrophoresis, जब हमारा जल load हो गया, in the tanks we will add the buffer. Buffer we were already having TB buffer. Then electrophores it at 80 to 120 volts. A particular amount of voltage is given and amount of current. So that's why our part जो है उसमें adjustable है. We will give it 80 to 120 volt voltage, 60 to 70 milliampere of the current until the dye travels 3 to 4 centimeter. आपको जो dye है वो चलती हुई दिखाई देती है. 3-4 centimeter चल लिया तो आप उसको रोक सकते हो. Or you can give additional 10 minutes for better resolution also. हमारा electrophoresis जो है that can be completed within 1 hour. So we will see कि 1 hour में जो है dye काफी आगे चली जाएगी, वहीं पे हम इसको switch off कर देंगे. Now when you switch off, you can take out your gel from the template. You can see that there are some visible bands there, but those may not be very visible. ज़्यादा visible नहीं होंगे. To make them good visibility, we incubate it in the moist chamber. एक हम factory place के chamber prepare करेंगे. We will have the moist cotton in it, and we will keep the gel in that and overnight incubate it at 37 degrees Celsius. Next day, you can see these peaks which are coming. So here you can see the peaks 1, 2, 3, 4. These were of the standard antigen. In the last 2 wells, we were having the test antigen. So we will see that this is lying in between this particular concentration, and exact concentration we can prepare if we plot a graph. You will take a graph paper, and on one axis you will plotting the height of the rocket, and the other axis will give you the concentration in the unit. Most probably it will be the microgram per ml. So A, B, C, D, the standard antigens, then E and F, these are the test antigens. You will record their height and you can plot it on the graph to have the exact concentration. So like this, you will prepare your graph. ये आपका standard graph बन गया है, and the red color is showing the unknown sample. You will plot the unknown. यहाँ से extrapolate करके you can find out the concentration of your antigen. So this will give the exact concentration of the antigen present in the unknown sample. Now, why to do this technique? What is the application? As आपने देखा इसका historical importance क्या था? It was used for the quantification of a virus present in the chicken. In the present context, we can do it for the qualitative as well as for the quantitative analysis. Different serum proteins को quantify कर सकते हैं. We can determine the concentration of specific protein in sample. Serum में abnormalities हैं. Some Ig is heightened, some अलग Ig produce हो रहे हैं, और there are some abnormal proteins which are produced in urine, in the CSF, pleural fluids. These abnormal proteins give the indication of some inflammatory reaction or some cancerous conditions. तो हम इस conditions में इस technique को carry out कर सकते हैं. It can using this we can quantify the protease, immunoglobulin protease activity also. So we can also use it for different purposes depending upon the requirement. So depending upon the requirement, we will take the diagnostic kit and we will use it for particular diagnosis. This technique can also be used not only for the infection purpose, not only for diagnosis, but we can also use for the research purposes. We are having number of materials which contains the antigens like the plant material, animal tissues, microbial extracts. In the market, you can see that when there is a food product, some are the food supplements. They are ensuring you take the supplement and you will have good health. It is nutritious for you. It will give boost your immune system. It will give a number of the health benefits. But they may be containing some antigenic components in them which may be harmful for you. So that is used in those industrial research purpose. So see, if there is an antigenic component present, जो उसको manufacture कर रहे हैं, तो साथ में कुछ antigen तो नहीं आ रहा जो कि undesired है. अगर आ रहा है, तो उसकी permissible limit होनी चाहिए, उससे कम ही आना चाहिए. So that is used by the industries when they are doing their R&D for a product. So quantify how much antigen is present there. One research paper is there in which the amount of casein present in food sample is quantified. So casein is the milk protein. Kitna milk protein hai? Different samples they have taken. So battered the content of the milk casein, so that will be having a good nutritional property. So it can be also compared for the used for the comparison of certain components in the food item. So that's why you are going to learn this technique. It has got the numerous application in the research as well as in the academics. So now that if you're having any question related to your principle and the methodology, you can ask the question, and we are starting with the practical part also. Yes. Sulfates. Actually, there are agros. It contains number of ions. Although हमने बोला कि दो monomers हैं, but it has some negative anions like the sulfates, some carbonates also. When there is the process of the, or we can say the electrophoresis, then during the electrophoresis, these sulfates and carbonates, they will form a negative, if they're present, they will form a negative channel. A negative zone will be formed, and that can hinder with the movement of the anions. As anions, they are going towards the positive charged anode, so when they are encountering, they can be form a channel type, their motion, they can get hindered. Not a streamline motion, it will go zigzag, or certain channels, certain bands will be formed, so that can interfere with the quality of the results. The bands which we will obtain, those won't be the sharp bands. So lesser the quantity of these negative ions like sulfate ions, better is the agros. So agros की क्या होती है? There are grades. Which one agros to choose, that depends upon requirement of experiment. If there is lesser amount of sulfates, then more pure is that agros, so that is preferred. So that determines the grades, quality as well as the cost of agros. The which are pure, which are having lesser of the sulfate, those are more pure and they are used for more specific purposes. So if there is no more question, you can ask the questions in between also. Yes?
Ma'am, can we perform it with positively charged antigens?
This particular technique, if we are performing it positively charged, so that will hinder with the result. हमें क्या करना है? Anion ही लेना है, and we are moving it towards the cathode. So the antigen is such that we have made it negatively charged. If you are doing it for the positively charged, so that will change the amount of the buffers capacity and the charging charges on the buffer. So it can be modified. The technique can be modified for the positive ions. So that will require a lot of change in the setups also. So we are starting an experimental setup. You can focus the camera here.
Denise.
The students, can you see it from back properly, or you can stand up? This is the assembly for electrophoresis. The horizontal.
Hello.
Here there is a tank and there is the template. In the tank, buffer will be loaded. So we require this assembly. Then this is the power supply. The red one, it is the anode. This is the cathode. So the green wires will go in the anode. The black one will go into the cathode. This is the glass plate. Okay. This glass plate, last time you have also used this glass plate. Now this glass plate, first of all, we have made up some kind of wall with a tape. We have wrapped the tape all the sides so that when we pour the gel will not flow away. Okay. So this is the gel plate on which we will make the gel. The gel will be made of the agarose. This is the solution of agarose. Okay. You can prepare it yourself also. How is this prepared? 1% in the buffer. The buffer is the TBE buffer. So buffer is there in the kit. You will take the buffer, prepare it, then you will add the agarose and dissolve it by complete boil. The kit contains the antigen, they are the standard antigen, the antigen 1, 2, 3 and 4. Then there are the sample antigens. And there is the anti-serum. This anti-serum has to be added 13 microliter in 10 ml in 50 nano. Okay. So according to that, you will adjust on a single plate. Kitna aata hai? There is approximately we at 10 ml, 10 to 15 ml. So you will prepare according to this. You will add the anti-serum into the gel. This gel is the agarose gel. Now that its temperature is tolerable. As I am feeling it, it is neither too hot, neither too cold. So we will add the amount of the anti-serum to this gel, and then this gel is poured off. When we pour off, then make it is sure that it is placed on a horizontal surface, and during pouring off, there should not be any bubble. If bubble comes, then it will interfere with the movement of the ice. So if there is by chance any bubble, then we will take a pin and we will prick that bubble. So when the gel has been loaded, then in the moist chamber like you have used yesterday, the packet plates having the wet cotton. You will keep in that for 30 minutes. And then we will, when it gets set up, then we will load the antigen in it. So loading the antigen, following the antigen, this is the puncher, gel puncher, which you have also used. We will do the gel puncturing out of it. The gel which is prepared, that gel will be loaded with the antigen. So you are having the template. When you will load, make the gels, keep this template in there. Stencils, we can call it stencil. So you will keep this stencil and then you will puncture out the wells. Then you will load your antigen and keep it by keeping it inside the on the assembly. You will add the buffer and switch on this assembly. Okay. So first of all, what we can do, we can pour this agarose on the glass plates, and one of you can prepare the moist chamber. take the cotton, dip it, soak it in the water, and prepare the moisture. Now that you can feel the temperature, feel it like this. How is it? Bearable, okay. So I think while we add the antiserum to it, it may get solidified. So I'm giving it just microwaving of 10 seconds so that it becomes a bit warmer and we can add the antiserum. So that's just the second step. ठीक है करते करते एक दफा करते नहीं फिर solidify. ये तो सर को बता दीजिए.
सर भी एग्जाम में भी है कौन सा
तो ये पूछना है कि जैसे 30 मिनट में चलता है उसके बाद 30 मिनट के लिए इसको बंद करना है. ठीक है.
सर मैं बात कर रही हूँ ना मैं देख
सर 30 मिनट का ड्यूरेशन है जब बना के उसको सेट करूँगा तो 30 मिनट मतलब ये स्टेमिंग बता दीजिए बताइए सर कॉल करिए.
मोनी इधर को चले जाओ ना कुछ है इधर को पूरा आएगा ओके.
So pay attention here. This is the arrows 1%, 50 ml of this. To this we are adding 962 microliter. $50 ml agarose, 1%. (962 microliter of the antiserum. Now the antiserum contains what? Antibiotic. So this temperature is not tolerable. It is neither too cold, neither too hot. Once we add this antiserum, then we will mix it by rotating properly. So there is uniform distribution. And as soon as we add, you will make your gel. You will add it on your glass plate. And then we will incubate it in the moist chamber. This is the autocupate which we are using 100 to 1000 microliter. Who wants to add? Come one by one.
दिनेश
Still photographs still photographs नहीं है. Come from someone from Science Institute, come past. Science Institute. Next chance for PGIT. PBIT. Come.
तो शादी के बाद एंड
Excuse me.
दिनेश इधर
अब इसको हम पैकेजिंग थोड़ी देर or sometime, after some time, let it get set. Then we will keep it in the moist chamber. This is the moist chamber. We have prepared it by soaking the cotton in the water. So this cotton is only damp, not wet. Should not be dripping. Okay, so it is just moist. And now let it get set. Then we'll keep the gel by removing the tapes in this chamber and keep it in the refrigerator for 30 minutes to allow the gel to set. पाँच मिनट के लिए 5 minutes. Students, pay attention there. Now, as your gel is getting solidified, we are keeping it in the refrigerator. So this session, I am giving you the break of 30 minutes. You can go, you can refresh yourself and come exactly after 30 minutes. Then this will be continued and we will load the gel and continue the experiment. So you can disperse off exactly but come after 30 minutes.